Alright, so here we are on lesson 17, relating scale drawings to ratios and rates. So this first definition here is of a scale drawing, and that's a drawing in which all lengths between points or figures in the drawing are reduced or enlarged and proportional to the lengths of the actual picture. A constant proportionality exists between corresponding lengths of two images. So there's some big words that we've seen and we've been seeing this whole unit, such as, constant of proportionality, proportional, and things like that. So scale drawing, this is kind of our first introduction to it, and we're going to talk a lot more about this as we move through the rest of the topic. And then the second definition here is a reduction, and this is the lengths in the scale drawing are smaller than those in the actual object or picture. So if you think of when something is reduced, it gets smaller. So you can think of that when you see reduction. And the next one is an enlargement, and that's when the lengths in the scale drawing are larger than those in the actual object or picture. So again, when something gets enlarged, it grows, it gets bigger. Right. So in this first example, it says, are the pictures below an example of a reduction or an enlargement of the original picture? So first we have a fingerprint here, and if you pause the screen and look at your finger, I think you can tell that this picture is an enlargement. It's bigger than your actual fingerprint. So we're going to label that an enlargement. And then the second one here is of a map. And if you think about, a map, whether it be on your phone or a paper copy, that's usually a smaller version of what the city actually looks like, right? The city of Geneva wouldn't fit on one 8x10 piece of paper, but they make it happen. So we're going to label this as a reduction. All right. So if you go ahead and flip over to the next page, we're going to skip this page, and we're going to go on to the page where it says example 3. So this says, Emma drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. So we have this original and we have the second drawing. So we're going to look at the original drawing at the lengths. And if we look at the length across the bottom here, we're going from 7 over to 13. So that is 6 units long. And then if we're going vertically, and if you go from the bottom all the way up, that is 18 units. And we're going to compare that to the second drawing over here. And if we look at the bottom, we're going from 7 to 10, so this is 3 units. And then if we're going vertically, we're going from 0 up to 9, so we're at 9 units. And then the tables, we're going to label X and Y just as we have been. The top is X, the bottom is Y. Because the next question asks, how are the scale drawings related to rates and ratios? So, one solid go-to is always using K, and we know K is Y over X. So for that first one, if we take Y over X, we would have 3 over 6, and if we simplify that, we get 1/2. And then if we do the other half of the measurements, we would have 9 over 18, and when we simplify that, we also get 1/2. So we can say that our K is 1/2 for this set of measurements. And it asks, are the pairs of corresponding lengths proportional? And we can say yes. And then it asks, what needs to exist in order for an image to be considered a scale drawing? And it needs to have the scale factor or constant. So this constant K is also known as our scale factor. Then it asks what is the constant of proportionality, and we found that out to be 1/2 when we calculated Y over X. Then it asks, is the second image a reduction or an enlargement of the first image? And just by looking at it, we can tell that it was a reduction. Alright. So that's all for this page. We're going to go ahead and flip over to the next page and try one more all together here. And this one says that William drew and cut out a small right triangle for a mosaic piece he was creating for art class. His mother really took a liking and asked if he could create a larger one for their living room, so William made a second template for his triangle pieces. So again, we're going to measure the lengths here. So for the original, If we do the horizontal measurements, we're going from 5 over 7 to 8, which is 3 units. And then going vertically, we're going from 0 up to 5, so that would be 5 units. And then in the second drawing, if we're doing the horizontal measurements, we're going from 5 to 15, which would be 10 units. And then our vertical measurements, we're going from 0 up to 15, so we'd have 15 units. Again, label your table, X on top, Y on the bottom. So the first part says to set up a ratio of the corresponding sides. So if we're still going to do Y over X, we'd have 10 over 3. And if you'd like to simplify that, that would be 3 1/3. And then our other one is 15 over 3, which would just simplify to 3 over 1. See? So this would be 3 over 1. And it asks, are the pairs of corresponding lengths proportional? Why or why not? And when we look at this, we can say no, because they do not have a constant of proportionality. So they don't have a K here, because the one was 3 1/3 and the other was 3, so that means that they're not the same. And the next question said, would William's image of the original mosaic be considered a scale drawing? Why or why not? We would say no, because you need to have a constant. And then it says, is the second image a reduction or an enlargement of the first image? And even though it's not a scale drawing, we still could say that it was an enlargement, just simply because it got bigger. Alright, so that's all we're going to do for this lesson. If you have any questions, obviously bring those to class, and then we'll do some more practice all together.